Welcome. In this lesson, we're going to build a small, interactive program from scratch using fundamental Python concepts. By the time we're done, you'll have a program that can ask a user for their name and age, and then use that information to create a friendly, personalized introduction. Think of it as your very first step into making programs that actually talk to people. We'll start with the absolute basics, like how to store information, and gradually add more pieces. Every step will be explained clearly, ensuring you understand exactly how each part contributes to our final, simple, but very cool program. Ready to dive in and create something useful? Let's begin by understanding variables, which are like labeled containers for storing information. To create a variable, you give it a name, like greeting, and then use an equal sign to put a value inside it. For example, we can write greeting equals hello Python learners. Here, greeting is our container, and the text hello Python learners is the value stored inside. To see what's in our container, we use the print function. If you type print greeting, Python will display hello Python learners. Notice how the variable name is always on the left of the equal sign, holding the value on the right. What do you think would happen if we tried to print a variable that hasn't been given a value yet? Variables are not set in stone. You can change the value stored inside them at any time. This flexibility is incredibly useful in programming. Let's say we have our greeting variable currently holding hello Python learners. We can update it by simply assigning a new value to the same variable name. For instance, if we then write greeting equals welcome back, the old message is replaced. If you were to print greeting again after this update, you would now see welcome back displayed. The program always refers to the latest value that has been assigned to a variable. It's like changing the contents of a box without changing the box's label. This ability to update information is a core concept in programming. Just like in the real world, where we have different kinds of information, like words, whole numbers, or numbers with decimals, Python also categorizes data. These categories are called data types, and Python needs to know what kind of data it's working with to handle it correctly. For instance, you wouldn't try to do math with someone's name, right? In Python, we'll focus on 4 fundamental data types: strings for any kind of text, integers for whole numbers, floats for numbers that have decimal points, and booleans for simple true or false values. Understanding these types is crucial for writing effective and error-free programs. Why do you think Python needs to know the difference between a name and an age? Let's look closer at 2 common types. A string is essentially any sequence of characters, whether it's a single letter, a word, or a whole sentence. You create a string by enclosing the text in either single quotes, like hello, or double quotes, like Python. Our hello Python learners message from earlier was a string. Integers, on the other hand, are whole numbers, positive, negative, or 0, without any decimal points, such as 5, -10, or 0. You can perform mathematical operations like addition or subtraction directly with integers. Now, here's a quick check. What do you think would happen if you tried to directly add a string, like my age is, and an integer, like 30, together in Python? Moving on, floats are numbers that include a decimal point, like 3.14 or -0.5. They are used when you need more precision than whole numbers can offer. Booleans are the simplest type, representing just 2 truth values, true or false. Python is quite strict about its data types. If you try to combine a string and a number directly, for example, by trying to add them, Python won't know what you intend to do. It can't assume you want to join them as text or perform a calculation. This will result in a common error called a type error, which means you're trying to perform an operation on incompatible types. This strictness helps prevent mistakes and teaches us about type compatibility. Since Python is strict about combining different data types, we often need to convert one type to another to make them compatible. For instance, to combine a string and a number, you typically need to change the number into a string first. This is where the str function comes in handy. If you have an integer, say age equals 30, and you want to join it with the string my age is, you would use strage. So my age is plus strage would correctly combine into my age is 30. The str function takes whatever is inside its parentheses and converts it into a string, allowing Python to then join it with other text. This way, Python understands exactly how you want to combine the pieces of information. Want your program to get info from the user? The input function is essential. It pauses, shows a message, and waits for user input. Whatever the user types is returned as a string, which you can store. For instance, name equals input, what is your name, asks for a name. Remember, input always gives a string. The input function always returns a string. To perform calculations, convert this string to a whole number using int. For example, age equals int, input, how old, converts 25 to 25. However, if the user types hello, int will cause a value error. It only works for valid whole number strings. When user input is a valid whole number, int works perfectly. If input gets 30, int of 30 successfully converts it to the number 30. Now you can perform math with this true number, like adding to their age. This conversion is crucial for accurate calculations using numerical data from the user. Now we can join the pieces into one interactive greeter. We store the name, turn the age text into a number with int, then use strage when joining the number into our greeting. The result is a program that uses variables, text, a whole number, and real user input together. Your turn. Pause here and predict the greeting for the name Maya and the age 12. Then change the name or age yourself and run the same program again. The important idea is that the variables hold new values while the steps stay the same. You can now store values, tell text from numbers, and collect user input. In Part 2, we will use those same building blocks to make choices in a program. Keep this greeter nearby and try a few new names and ages.